All right, welcome to lesson 9.5. This lesson is on drawing or finding out area and perimeter of figures when they just give you coordinates. So we're going to be doing this stuff on coordinate planes. Let us start with example 1 to show you how you're going to be getting started. So this is one when they give you a nice, lovely coordinate plane to make your life easier. It says a rectangle has the vertices A, I'm not reading the numbers, B, C, D. Use the coordinates to find the length of each side, then find the perimeter of the rectangle. So when they give you the graph paper, this one is kind of easier. So A is at 2, 8. So over 2, up 8 is A. B is at 7, 8. C is at 7, 5. And D is at 2, 5. Now, if you have to find the perimeter of this one, first you got to know perimeter is the distance around a shape. So if you were doing this, all you would do is find the length of all the sides. So the bottom is 1, 2, 3, 4, 5 units. So will the top be. The left is 3 units. So will the right. 5 plus 5 is 10. 11, 12, 13, 14, 15, 16. The perimeter is going to be 16 units. Now, and you can see that down here. So that's an easy example, easier because they give you the coordinate plane. Now in example 2, they do not, and you're going to have to figure this out. Now, here is the good news. Let's say you don't know what the heck I'm talking about as I go over example 2. You can always draw a coordinate plane on your own and graph the points. It takes a little longer, but you do have a way to get your answer. But I am going to show you a way to do example 2 without doing that. So now I made a little box in example 1 just so I can show you the work that we're going to be doing here. So example 2 says, rectangle ABCD has the vertices A, B, C. I'm not reading the numbers. Use the coordinates to find the length of each side, then find the perimeter. Now remember, you can go through, get graph paper, and draw it just like this up here, but I don't want to do that. But what I usually do like to do is I like to actually kind of draw a very generic coordinate plane. Now I notice they're all positive, so they're all going to be in quadrant 1. So I'm just going to draw it kind of like that. Now, I'm going to kind of just think of like this is 1, 2, 3, this is 1, 2, 3, just to kind of get my rectangle in about the right spot. So if A is at 2, 1, if I can imagine going over 2, up 1, so I would just put A right here. And I'm going to write the coordinates for A is at 2, 1. B is at 2, 5, so I'd go over 2, up 5. So that would be, and that's at 2, 5. C is at 4, 5, so I'd go over 4 and up 5. So that's at 4, 5. And then D is at 4, 1, so over 4 and up 1. So I just wrote them down, and I don't need to draw anything for this, but this hopefully will make it easier to see. Now first off, it is a rectangle. So to find the perimeter, I have to find the length of all the sides. So here is the trick. We did this a couple chapters ago, but I bet you forgot. Since it's in quadrant 1, let's take a look at, say, this side here. Since it's a rectangle, if we could find the right, the left will be the same. So I'm looking at the coordinates for the two right points. The one is 4, 5, the other is 4, 1. So here is the trick. Ignore the ones that are the same, so ignore the 4s. And then subtract the ones that are different. So 5 minus 1 is 4. That means this side length is 4, and if the right is 4, so is the left. Now I'm going to do the same with the top, but I'll switch to blue this time. So I'm looking at 2, 5, 4, 5. Ignore the coordinates that are the same, and subtract the ones that are different. So 4 minus 2 is 2. That means this is 2, and so is this. So to find the perimeter, I'm going to add up my sides. I'm going to add up my 2 plus 2 plus my 4 plus my 4. That means my perimeter, if I add those up, will be 12 units. Okay, so I like to sometimes draw something like that, but you don't have to. So as we go over example A, I'm going to do A together with you, and then I'll have you try B. So in A, I'm going to, can I get rid of that rectangle? Let me get him out of there. In A, I'm going to do without drawing a rectangle. So the directions say, use the coordinates to find the length of each side, then find the perimeter of the rectangle. Now this is key because they told us it's a rectangle. So let me get this ready here. So I'm going to start to find, since it's a rectangle, I basically need to know the length of the four sides. So I need to know, say, the top plus the bottom plus the left plus the right. And if I add those up, I'll get the perimeter. Now I'm going to start with point E and point F. Now rather than drawing here, I'm going to do the same thing without the drawing. So I'm not going to pay attention to the 3's because they're the same. So the ones that are different are the 6 and the 8. So I'm going to subtract those. 8 minus 6 is 2. Now what that means, since it's a rectangle, is one of the side lengths is 2. And since it's a rectangle, another one has to be 2. Could be the top and the bottom, could be the left and the right. Now I'm going to go to this and this, F and G. So let me switch over to blue here. Now notice here the 8's are the same, so I ignore those. And then I go with the 7 and the 3. So 7 minus 3 is 4. So what that means is one of the side lengths is 4. And since it's a rectangle, I know the other one will be 4. Now, if you didn't trust that, you could always go and check, let's say, from G to H. The 7's are the same. 8 minus 6 is 2, so that's our other 2. And then you'd have to go all the way from H to E again. Notice in that case, I'll switch to black, the 6's are the same. And I'd have to do 7 minus 3, which is 4. But I already had that 4. So, to find the perimeter, I just have to add those 4 side lengths up. Let me get a little room. So 2 plus 2 plus 4 plus 4 is 12. So A is 12 units. Now, I want you to do B. Now, just remember, when you're looking, the number that's the same, you ignore. So you'll ignore the 1's and subtract the 9 and the 4. Since it's a rectangle, you're going to have 4 sides. And remember, 2 of them will be the same, and the other 2 will be the same as well. So try B, pause the video. When you're done, I want you to restart it, and then I'll go over it. Okay, go ahead. All right, let's see how you did. So I'm going to start in problem B. So I'm going to ignore the 1's, and I'm going to subtract the 4 and the 9. So 9 minus 4 is 5. So one of the sides is 5, a second must be 5 because it's a rectangle. And then let me go from 1, 9 to 8, 9. Now in this case, the 9's, switch to blue here, the 9's are the same, so I'm going to ignore those. And I'm going to subtract the ones that are different. So 8 minus 1 is 7. That means one of the sides is 7, and since it's a rectangle, a second side must be 7. So that's really as far as I need to go to find the perimeter. If I add these up, 5 plus 5 plus 7 plus 7, they will add up to 24. So my answer to B is 24 units. Notice it's not square units because it's just perimeter. All right, so let's go on to the next page. On this page, oh, this one's fun. This is one where they're going to give you some coordinates you're going to have to draw, and you're going to have to find the perimeter. So we'll go through, it's more of a real world example. It says, each grid square on the zoo map has a length of 200 feet. I am going to highlight that because that is so important for this problem. Let me get my highlighter ready. Okay. Each grid on the zoo map has a length of 200 feet. We'll see at the very end of this problem how that's going to affect what we're doing. All right, now, it says find the total distance in feet around the zoo. So here's what you got to do. As you're going over this one, you basically have to find the length of all of the sides. But here's the tricky part. When you're doing this, it is so easy to lose track of one of the sides. Maybe you'll forget that you found one side or didn't find it. So watch how I'm going to keep track of these. Now, first off, I'm going to figure out the length of this here. And I have 2 options to do. Now first, I'm going to trace it a little bit here, so I know I'm doing it. So the length of that side, here's option 1. You can actually count the squares. 1, 2, 3, 4, 5, 6, 7. All right, great, that was exciting. Or, like on the last page, you can ignore the coordinates that are different. So ignore the 10s, ignore the coordinates that are the same. Ignore the 10s, and subtract the ones that are different. So 7 minus 0 is 7. Now I'm going to write down my 7 right here. I also like to write it off to the side. Now I'm going to find this side here. Notice I'm marking the sides. That way I know I already found it. Again, you can just count. Like this one, since it's little, I'll probably just count 1, 2, 3. So that one's 3. And now I'm going to do this one. Since it's small, I'm just going to count 1, 2, 3, 4. This one's 4, 1, 2, 3, 4. Notice I'm keeping track of my numbers over here because I'm going to have to add those up. This one's 4. It's an easy one to count. This one's 3, 1, 2, 3. And this one's going to be 7 again because it's just like this top one. And again, I ignore the zeros and do 7 minus 0, which is 7. So that is 7. And then the last one, that one on the side. I don't feel like counting that one, so this is where the trick comes in handy. If this is 0, 0, this is 0, 10. The 0 in the x coordinate is the same, so ignore it. And then do 10 minus 0, which is 10. So that means this whole side is 10. Now you need to be very careful that you don't miss any sides. So here's kind of another thing I'll do. I'm going to go back and count the sides and make sure my numbers are the same. So I have 1, 2, 3, 4, 5, 6, 7, 8. I'm going to count my numbers. 1, 2, 3, 4, 5, 6, 7, 8. All right, so that way I know I got all of my sides. To find the perimeter, I have to add those up. You can use a calculator or a little mental math. 10 and 7 is 17, plus 3 is 20, 24, 28, 32, 35, 42. So that means the perimeter of this in units is 42 units. And right now you're like, okay, I'm done, easy 42. But no. At the very beginning of this problem, I had you highlight something, or I highlighted something. I don't know what you did with it. Each grid on a square has a length of 200 feet. So each of these 42, remember the perimeter was 42, is equal to 200 feet. So what you need to do to find your perimeter in feet is you need to take those 42 units and multiply it by 200. And again, you could use a calculator, but if I were doing mental math, I know 2 times 42 is 84. And I'm going to add on these two lovely zeros to get 8,400 feet, which is the answer. So be very careful because it is so easy to forget that in the beginning. Most people do, and very smart math people forget it all the time. So we'll go down. I'm going to get you set up for problem C, and then we're going to see if you can come up with it. Now, oops, looks like I wrote the wrong answer in problem C blank. Okay. So problem C says the coordinates of the vertices of a garden are 0, 1, 0, 4, 8, 4, 8, 1. If each unit represents 12 inches, find the perimeter in inches of the garden. So in this one, they don't have it drawn for you, but I'll give you a hint. There are 4 coordinates, which means it's going to be a quadrilateral, 4-sided figure. Now, it's probably going to be a rectangle or a square because they're not going to give you really hard ones in this. So I would figure out the perimeter for this one, just like you did A and B on the other page. Once you get the perimeter, don't forget that each unit represents 12 inches. You're going to have to do something to get your final answer. So give this one your best shot, and then, so you're going to pause the video, give it your best shot, and then restart the video to see if you're right. Okay, go ahead. All right, so I'm going to go over C. I kind of created a rectangle so I'd have some workspace to do it. Let me start out here. So remember I said it's probably going to be a rectangle, and it will be. So I'm going to even draw my rectangle here. Okay, so I'm going to start with a 0, 1 to 0, 4. Remember, ignore the zeros because they're the same. And do 4 minus 1, and I get 3. That means 2 of the sides are 3. I don't know if it's the left and the right, top or bottom. I don't really care either. Now, I'm going to go, let me turn on orange. I'm going to go from this one down to this one. So ignore the 4s because they are the same. So you have to subtract the ones that are different. 8 minus 0 is 8. So that means 2 of the sides are 8. If this is 8, then this is 8. Now you can keep going. You can check the next coordinates, but that's pretty much what it's going to be. Now, when I add those up, I have to do 8 plus 8 plus 3 plus 3. So 8 plus 8 is 16. 3 plus 3 is 6. That is 22 units. But remember, that is not your final answer. Did you remember here? It said each unit represents 12 inches. What is the perimeter in inches? So you have to take that 22 and multiply it by 12. And if you do that, let me see if I can do some mental math because I don't have a calculator. I'm going to do 22 times 10 is 220. 22 times 2 is 44. So 220 plus 44 should be 264 inches. Hope I didn't mess that one up, so let me know if I did. All right, I hope you got that one. Okay, are you ready for the next part? In the next part, it is all about finding area. Now, the good news is, you know how to do this, it's just area is going to make it a little bit different. So this says, you can find the area of a figure that has been drawn on grid paper or graphed on a coordinate plane. Find the area of the figure in square units. Now this is an irregular figure, so we're going to split it into two parts. We're going to take this rectangle on the bottom, and this is a trapezoid on the top. Now, first off, for the rectangle, you can do length times width, or you could even just count those squares. So you see how that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the area of that is going to be 10, or remember, this is 2, this is 5, 2 times 5 is 10. Now I like to write that 10 right inside the rectangle there. But the trapezoid, you're going to have to do a little bit of thinking because, why the 10? I want that to stay. All right. The trapezoid isn't as easy to count because you have these little partial pieces over there. So what I'm going to do is I'm going to get some dimensions with my formula. Remember the formula for area of a trapezoid. Why don't I get another lovely rectangle going here? Okay. The formula for area of a trapezoid is A equals half times height times base 1 plus base 2. And now I'm going to substitute some numbers in there. So I have area equals half times the height. So let's find the height. First off, the bases are parallel. So this is base 1, this is base 2. That means in red, this must be the height, which is 2 units tall. So it's half times 2. And now we'll go to my bases, times base 1 plus base 2. So base 1 right here is 3. See it? 1, 2, 3. Base 2 right here is 1, 2, 3, 4. So let me add those up. So base 1 was 3, plus base 2 is 4. And all I have to do is type that lovely problem in the calculator. Now if you want to do some mental math, remember half of 2 is 1, 3 plus 4 is 7, 1 times 7 is 7. So the area of my trapezoid is 7. That means to find the area of that entire figure, I have to add my 7 and 10 together. And if I add those together, I get 17 square units. Remember, we're moving back into area, so that has to be square units. All right, so now, problem D you're going to do on your own. It is not nearly as tricky as the example right before it was. So I'm just going to give you a little bit of a heads up here. It says, find the area in square units of the figure at the right. You have to identify what this figure is. I am not going to tell you that. So you're going to write the formula, then you're going to figure out the numbers by counting some blocks, and then find the area in square units. So pause the video, do D. When you're done, restart it and see if you were right. Okay, so the first thing is, did you recognize that that is a parallelogram? Because if you know it's a parallelogram, you know you have to do base times height. Now to find the area, you need to find the base and you need to find the height. So I'm going to start in red with the base. So you could pick either one of the top or the bottom sides for this one. So 1, 2, 3. The base is 3. Now for the height, I'll switch over to blue. Don't count the slanted sides. You got to go straight up to the other height. So if I count straight up, it's 1, 2. So the height is 2. That means the area in problem D is 3 times 2, or 6 square units. All right, are you kicking butt, or are you getting your butt kicked? If you're getting your butt kicked, be ready to ask me for some help after you're through this. One more, an awesome real-world example over here, and problem E. So we'll go over 5, and then you're going to try E. Okay, in 5, it says, A figure has vertices A, B, C. I'm not reading the numbers. Graph the figure and classify it, then find the area. Holy crap, look at all the stuff you got to do this one. You got to graph it, and then you got to classify it. In other words, name it. Is it a triangle? Is it a rectangle? Whatever. Then find the area. 3 stinking things. Now, I'll give you one hint. See how they only gave you 3 coordinates? Well, guess what? I know it's going to be a triangle because triangles have 3 points. So when I classify it, I can do that without doing anything else. Now, probably want to be a little more specific as you're doing it. So then you would graph those points. A is at 2, 5, over 2, up 5, right there. B is at 2, 8, over 2, up 8. And C is at 5, 8, over 5, and up 8. So I would draw it. It's so beautiful. And so I've already done with 2 parts. So first off, I classified it. Next, I graphed it. Now I have to find the area. Now remember, area for a triangle, you got to remember this formula, is half times base times height. So I'm going to write that down. Half times base times height. And I'm going to substitute. Area is half. Now, let me go up to my triangle. You see this right angle right here. That means these are the sides you must use for the base and the height. So they are each 3, so it really doesn't matter which one you use for which. So my formula, its area is half times 3 times 3. And if you type that in your calculator, you get your area of 4.5, and it's square units because it's area. Okay, now if you want to be fancy, you can say, hey, that triangle has a right angle in it, so when you classify it, it would be better if you classify it as a right triangle, not just a triangle. Because you know what? A 1st grader could know that's a triangle. A 6th grader needs to know it's a right triangle. All right. Last thing you're going to do with me before you do whatever else you have to do. In E, you have to graph it. Right here, it will make it beautiful. Classify it. What is that going to be called? I'll give you a hint. It has 4 points, so it's going to be one of those quadrilaterals. And then find the area, hopefully using the correct formula. Okay, do all 3 of those things. So pause the video, do it, and restart it when you're done, and we'll see if you're right. Go. Okay, how did you do? Let's see. I'm going to start by graphing my figure. So let me turn the pen on a little thicker dot here. So point A is at 3, 3. So over 3, up 3, that is point A right there. Point B is at 3, 6. Over 3, up 6, right there. Point C is at 5, 6. Over 5, up 6, right there. Point D is at 8, 3. So over 8, up 3, right there. Ooh, it is not a rectangle. I thought it was going to be a rectangle. So I'm going to connect those dots. And 1, 2, 3, 4. So I graphed it. Did you classify it correctly? Guess what? It is a trapezoid. Now last, you had to find the area of that trapezoid, so I'm going to do that work above the graph here. Remember the formula. Area is half times height times base 1 plus base 2. Okay, I need to find the height, base 1, and base 2. So let me start with the height, which is right here, which is 3. So I have area is half times 3 times base 1 plus base 2. So now let me get the bases. Here's base 1, which is 2. And here base 3 is on the bottom, which is 1, 2, 3, 4, 5. Okay. So last, you just have to type that in your calculator. And if you type in half times 3 times parentheses 2 plus 5, you should get 10.5. So my area is 10.5 or 10.5 square units. So if you were able to get all of these, classifying it, graphing it, and finding the area correctly, then you need to give yourself a big pat on the back because you figured this out. All right, do whatever else you need to do. Be able to ask me questions if you are totally stuck. Thanks, guys.